Does time exist? And if it does, what is it in essence? Modern science answers the first question categorically in the affirmative, considering time as one of the coordinates of a single spacetime, the ideas about which are developed in the theory of relativity. But is this really so? If you turn to Wikipedia, then in the English language article about time we read literally the following: time dictates all forms of action, age, and causality, being a component quantity of various measurements used to sequence events, to compare the duration of events or the intervals between them, and to quantify rates of change of quantities in material reality or in the conscious experience. This thesis contains an implicit absolutization of time, which, in turn, gives rise to a number of misunderstandings and erroneous conclusions. In fact, in nature, in the universe, time does not exist as a separate entity, like matter or energy. So what is time? It is simply an interval estimate of the observed changes. In other words, time is inextricably linked with the observer and his ability to register the changes that occur. Therefore, an incorrect estimate of the process leads to erroneous conclusions about the time with which these changes occur. It is important to note that the world around us is the result of the correlation of many different physical processes. The rate of change of the parameters of these processes is generally different, therefore each process, as a form of transformation of matter, has its own time. Time does not exist outside matter, just as there is no single universal time. Therefore, time should not be absolutized. Only the relativity of physical processes and observation of them is absolute. There is another aspect that should not be forgotten. Any real physical process is irreversible. This follows from the second law of thermodynamics, according to which the entropy of an isolated system increases with time and cannot decrease. Another way to formulate this is that heat cannot spontaneously move from a colder body to a hotter one. In a broad sense, it is quite possible to talk about the impossibility of a spontaneous transition of energy from a low level to a high one. From the irreversibility of physical processes follows the irreversibility of observed changes, which is expressed in the understanding of the unidirectionality of time. But since time is a function of the observer, the arrow of time is the understanding of the irreversibility of the observer's own physical processes. In the context of the topic of time, I would like to touch upon another problem related to understanding the evolution of the universe. Based on the literal understanding of the previously mentioned second law of thermodynamics, our universe is threatened with heat death. This theory has gone through several stages of its development, sometimes being refuted, sometimes being confirmed again. Today, the role of killers is assigned to black holes, due to which the total entropy of the system grows. In my opinion, the most plausible description of the universe is the concept of dynamic equilibrium for a closed system. This is when the processes occurring inside do not affect the state of the system as a whole. Imagine the universe as a huge closed system with constant entropy. I note that this idea does not contradict the second law of thermodynamics. In this system, interconnected physical processes occur, the totality of which ensures the equilibrium state of the system as a whole. Energy does not appear from nowhere and does not disappear anywhere, but simply passes from one process to another. Important note: the correlation of all physical processes between themselves is an inconstant value and depends on the degree of interconnection of the processes between themselves. But, nevertheless, correlation exists between processes that at first glance cannot interact with each other, influencing each other. This state is very figuratively described in the story by Ray Bradbury, A Sound of Thunder, when a traveler to the past accidentally crushed a butterfly. And in general, when studying physics, turn on your imagination, because according to Einstein, imagination is more important than knowledge. Knowledge is limited, while imagination embraces the whole world, stimulating progress, generating evolution. I don't know whether the great physicist said this or it was attributed to him, but I only partially agree with this thesis. Still, the imagination of the observer is clearly not capable of generating evolution, but it is capable of giving it a correct interpretation.